Well, let's take a look. So I listed the three criteria that must be met for a function to be continuous at a point. Okay, for the first one, here, we can see the limit exists, but f of negative 4 does not exist. Okay, f of negative 4 does not exist here. Okay, you put in negative 4 as an input, your output is nothing, doesn't know anything. Okay, same here. F of, you could say f of negative 3 does not exist. You could also say that the limit doesn't exist, because the limit really doesn't exist here either. Okay, but if you go down the list, the first thing you want to try is, does the function exist at that x value? Okay, and so you just go one by one, go 1, 2, 3 actually, and you'll see as we go here. So the first criteria, is it met? F of negative 2? Yes, f of negative 2 does exist, it's right there. Okay, does the limit exist? No. So we would say at negative 2, the limit as x approaches negative 2 of f of x does not exist. So I'll remind you what we're doing here. What we're doing is we're trying to indicate why the discontinuity, fails the formal definition of continuity. Why is it discontinuous at negative 4? Because f of negative 4 doesn't exist. Okay, so this is normal, and this is important that you're able to distinguish the calculus reason why a function is not continuous at a certain point, because sometimes you're going to have to convince someone like me, the teacher, that you understand what you're doing, and on a test you'll be asked why is the function discontinuous, let's say at 3, and you'll have to provide the information like one of these answers. Okay, so at 3 we can see we have an infinite discontinuity, and we can also see the function doesn't exist at 3, so we would say here that f of 3 does not exist. Okay, and then 4, this is the best one, because you have to get all the way to the third one, because you can see that f of 4 does exist. We already talked about that. We can see that the limit exists. We talked about that as well. But for the function to be continuous, the limit has to equal the value of the function, and so we would say f of 4 does not equal the limit as x approaches 4 of f of x. I think the video may have started over, but that's okay. We will let's go right into number 7 here. Now let's go ahead and scoot on down here to number 7. These are kind of fun problems as well. Where is f of x discontinuous? This is where we get into knowing and understanding the piecewise functions, and each piece here is here, the top one here, the top piece is a rational function, and the bottom piece, y equals negative 1/4, that's just that's a horizontal line, and that happens to occur at 2 and negative 2. So you could draw the graph, but more importantly, you can try these without the graph. See, this is rational, so the function is only going to be discontinuous possibly where we have an x value that makes the denominator equal to 0, which we have 2 and negative 2. So 2 and negative 2 would be the only possibilities in which this function f of x is discontinuous, because it's defined to be this top piece, which is a rational function, and this rational function is continuous everywhere except for whatever makes the denominator equal to 0. So the idea here is, if we want to find out where the function is discontinuous, we want to look at the three criteria. Does f, let's try negative 2 first. What is f of negative 2? Well, f of negative 2, it says, is negative 1/4. So the function exists at negative 2. Okay, let's try the other one. F of 2, let's put that over here so we have more room. F of 2 is also negative 1/4. Because you know, in a piecewise function, you have to find the domain restriction, and then you go to the left to see what you get. Okay, well, what's the limit then? So far, both of our possible discontinuities have survived the first test for discontinuity. And so we found that the functions do exist at negative 2 and positive 2. Function does exist. So then we want to take the limit as x approaches negative 2 of f of x. Well, in order to find that, we have to factor the numerator and the denominator. Okay, so if we factor the numerator, x plus 3 times x plus 2, and then the denominator would be x plus 2 times x minus 2. Okay, when we factor the numerator and we cancel the x plus 2 factors, we can see that we're going to have a hole at negative 2. That's going to indicate to us that that the limit will exist. And when we replace x with negative 2 in the numerator, we get 1. And in the denominator with negative 2, we get negative 2 minus 2, we get negative 4. So the limit exists as x approaches negative 2. So negative 2 has survived the first two criteria, and we can see that f of negative 2, is a great example, is the same as the limit as x approaches negative 2. So the function is continuous at negative 2. So negative 2 can't be one of our solutions. Okay? So we still have the possibility that it's discontinuous nowhere. We have the possibility, well, it can't be discontinuous for all real numbers. We already talked about that because it's a rational function that will be continuous for all real numbers except for whatever makes the denominator 0. So the all real numbers scenario is not going to work for reasons we just talked about. But then finally we have only one more possible discontinuity, and that's at 2. We know that f of 2 is negative 1/4. Okay? But what's the limit as x approaches 2? The limit as x approaches 2 of f of x equals, well, now when you try to plug 2 in, we can see 2 would make the denominator equal to 0, and 2 would make the numerator equal to 5, so we have 5 over 0. And then we have to figure, well, what's the limit from the right? Well, the limit from the right would be positive infinity, and either way we get negative or positive infinity, and so the limit doesn't exist. And certainly the limit will not be a real number. Okay? All of that being said, we know that now, since the limit as x approaches 2 does not equal the value of the function at x equals 2, we say that the function is discontinuous at x equals 2. Okay. That's it. I'm looking at 8, 9, and 10, but I'm thinking you might have enough information now to do 8, 9, and 10. I'd like you to try those. I'm going to do in a video number 9, and then I'd like you to do numbers 8, 9, and 10. Maybe you try number 9 as well without watching the video, and then watch the video to check your solution. So the next video will be just number 9.